Hello, my name is Chris Martinez, and I want to present to you my key activity project, which theme is hot water racing. To get started with the introduction, the main reason why I chose to do this experiment is because I am very intrigued to know the multiple functions of water and how it can be altered depending on multiple factors. Just as I was very intrigued to know the power that density has in water and the effect it had on it. It is something quite interesting to know due to the fact that everything in the world is mostly based on water and the way it works. It's amazing. So what are the main objectives through this experiment? Well, in the pair of bottles with hot water at the bottom, the cold water sinks and the hot water rises so that it floats on the top. In the process, the two mix. In the pair of bottles with the cold water on the bottom, there is no movement because the cold water has nowhere to sink to. So everything stays in perfect layers. So we could begin with the experiment. Let's see the materials we will be needing. We'll be needing 4 see-through bottles, a jug of cold water and a jug of hot water, food coloring, a teaspoon, a funnel or a large straw, scraps of thin card or paper, waterproof tray or sink. The methodology. We have to introduce the variables, which are the principal factors here. In the dependent variable, we have the convection. What is convection? Convection is the time it takes to the temperature to increase to a certain degree. The independent variable is the temperature, and the control variable is water. Well, now let's see how we are going to do this experiment and the steps to follow so we can achieve in the correct way this experiment. Well, I will be starting elaborating this experiment by choosing different food coloring for the hot and the cold water. In my opinion, I choose for hot red and for cold blue. Then I'll add a small amount of food coloring to the water jugs, giving each jug a good stir with a spoon. Fill 2 bottles all the way to the top with cold water and 2 to the top with hot water. Then putting 1 hot water bottle and 1 cold into the drip tray sink. Put the card over the top of the cold water bottle, holding the card in place. Flip the bottle over and then balance it on the top of the hot water bottle. The same with the hot bottle, balancing it on top of the cold water bottle. Carefully remove the cards, separating the bottles, making sure that the bottles stay balanced, and watch the reaction. To have a more noticeable view, here are the measurements. As you can see, we have a cold water bottle on the top and a hot water bottle on the top. As you can see, due to the fact that the hot bottle of water is less dense, when we have it on the top, it mixes with the cold water. But when we have it on the bottom, doesn't happen a thing. So the results of the experiment are this, theoretical and experimental. And the graphs are this. So both graphs, as you see, have pretty different results from one another. This is due to the fact that the time is not always so precise, and the temperature can be affected to the environment it encounters, but it almost has the same figure, this since both graphs are measuring the same thing and have to be similar. Summing up, the value of the independent variable greatly influences the dependent variable and the results that the experimental provides us. Since the temperature plays a more important role here, knowing that we measure the density of the water depending on the boiling time. Clearly, the experimental results can be improved by having better awareness of the environment in which it is implemented and the exact amounts of time when the water evaporates. Thank you.